Hello and welcome back to Mr. Powers Teaches Algebra. Well, we're solving exponential equations, and we had a method we used for exponential equations. We had a couple methods. In the last video, in this one, we are going to employ another method. And we're going to use this idea that exponential functions are functions. And it's this property that if you have a to the x equals a to the y, then x equals y. There we go. Sorry. Okay. We're going to use that property, which is a little bit different than what we did before. See, now the problem we have here, what's different between this one and let's say this problem. Okay, here we just need to get the x from out of the exponential position, out of the power, right? And there are two ways to do that. Here, we got the variable in the exponent, but it's on both sides. That creates another little issue. But if we're in this case here, where it's obvious that we got, where we can get the power, the base to be the same on both sides, then we might just want to do that. Just like, okay, let's get this base of 6. Let's get this the base of 6, because I can see they're both powers of 6. And then get rid of my bases and take a look at set those exponents equal. So there's our strategy for these. So I'm going to do a little bit of, let's see here, a little scratch work. 6 to the 1 is 6. 6 squared is 36. 6 cubed, that's b times 6 here. That's 6 times 3 is 18. So 180 plus 36. There's my 216. Okay. There we go. Okay, so they are powers of 6. So first thing I'll do on this is say, you know what? Okay, this is still 6 to the 2x plus 5. And over here, my equals 216 to the x minus 4. I can rewrite this as this 216 as 6 cubed. So I'm going to write 6 cubed to the x minus 4 now. Right? I didn't change anything, but I made it look different. Okay? Now that I have done that, what I can do is, well, almost. I almost have just the 6 to something, just 6. There, I got 6 to something to something. Let's fix that. A power raised by a power, we have a property for that. You multiply the exponents. So I'm going to do that first. So 6 to the 2x plus 5 equals, oops, hold on, equals 6 to the, distribute 3 into the x minus 4. So it would be 3x minus 12. All right. Now I have the same base. We can just bring those exponents down, and that's our life. Is we got 2x plus 5 equals 3x minus 12. Solve it. All right, so let's see. I want to get all my x's on one side. I don't like it. So I think I'm going to just get rid of my x's on the left. That way I only have x's on one side because I x's both. So let's minus 2x. Whatever I do to one side, do to the other. I also want to get rid of the numbers on the right side. So I might as well do that. I'll add 12 to both sides. Do it all in one step, as I like to do. And so 2x minus 2x is 0. 5 plus 12 is 17. I get 17 equals 3x minus 2x is x. Negative 12 plus 12 is 0. Okay, great. I'm done. I solved it. X equals 17. Finished. Complete. Adios. Done. Too easy. Can't believe how easy that was. And, you know, I stole this from Delta Math. Plug that in. We can check it. Bam. And of course, it always gives us nice worked out solutions in case we want to see how they did it, which is the exact same way we did. Oh, well, a little different, but we got 17. All right, next problem. This guy. Let's practice that. Although I'm not sure we're going to do anything different, it's going to be the same method. It's just the equations at the end might be a little trickier. And that's something you want to keep in mind. And for the last ones that we have assigned you guys, these turn into quadratic equations. So we're gonna have to be careful with those as we solve these. All right? Okay, let's go. Let's solve this one. And that'll do it for this video, I think. Okay, so that's a power of 2. 32 is a power of 2. I can definitely do that. Let's do a little bit of work over here. 2 to the 1, 2. 2 squared is 4. Got 2, 4, 8, 16, 32, 64, and 128. 2 to the 7th. Unless I made a terrible mistake. There we go. 2, 4, 8, 16, 32, 64, 128. Okay, it looks good. 2 to the 7th, 128. 2 to the 5th, 32. So what's 2 to the negative 5th? 1 over 32. So that's what we got, 1 over 2 to the 5th. Okay, so here, now we can go straight to my next step. This guy, 128, is 2 to the 7th. So we're going to write this as 2 to the 7th, all raised to the negative 5x minus 9 equals, this guy we can see is 2 to the negative 5th, all raised to the 5x minus 14. Right. Distribute, because a power raised by a power, we distribute. So this is really 2 to the negative 35x minus 63 equals 2 to the negative 25x. And we're distributing again. Negative 5 times negative 14 is positive. What do we get? 50 plus 20, 70. Okay. And now I have the same base. Once my bases are the same, we can drop them and set those exponents equal to each other. We get negative 35x minus 63 equals negative 25x plus 70. And I don't think I'll finish it. That's enough. If you're really interested at seeing what the answer would be, because, I mean, from there on out, it's old stuff. We're solving equations. And we know how to do those. It just gives us an excuse from this point on to practice some old strategies for solving equations. So here they went ahead and dropped the base a little earlier, but they get to the same point, and then we solve it. We get x equals negative 133 tenths. Not bad. Piece of cake. All right. So I hope you found that useful. And until next time, enjoy doing math.